Hello and welcome back. My name is Corey and you're my rubber ducks for the evening, and this is the series of episodes where we are creating a programming language from scratch using our basic skills with modernish C++, all in a command line terminal window. Vim is our text editor. And what we're looking at today is we are going to be coming up with a way of loading our own custom libraries into our program. The idea is we want someone else to be able to write a library that our library can utilize. And yeah, that's what we're going to do. So this is a kind of a meta approach of, we're designing a library that can use other libraries that we don't know what's going to be in the library. The main thing that we need is there's a communication that has to take place in general. So remember, Tang is, if you saw the last video that I created where I kind of broke down what is Tang and how does it fit into the standard programming paradigms, Tang is a library in and of itself. It is a shared object. It's compiled as a shared object or a dynamically linked library. But it is a library that you write a program that will implement Tang. And also, the way I designed it was that Tang, remember, that is the engine that can parse code and then execute that code as a program, right? It parses it into and compiles it into a bytecode, and then it can execute that bytecode. And you say, Corey, why are you reviewing all of this? Wasn't that in the last video? Yes, but it's been a couple weeks since I recorded that video, so for me, mentally, that's why. But anyway, so Tang is the library that provides that functionality, and it provides it in an object. Why? Because the intent is that you could have one object that has maybe one set of libraries installed, and it is self-contained, and then you could have another instance that has a completely different set of libraries. So what we need is a way to ask our library, Tang, the instance, the object, to load a library from the disk. And so what happens when we do that? Well, the library on the disk, our program has to try to load it. It'll either succeed or fail, but it tries to load it. And then what we're going to do is we're going to look for a function. So our Tang is going to look for a function in that target library. And if it exists, it will call that function, giving it a pointer to itself. And then it is up to that library to do whatever it wants at that point. That's where we're going to start, is with that idea. Don't know how much we'll get done today, but we're going to get started. On the right-hand side, as usual, we do our make clean. And on the left-hand side, we're going to do, no, not make. I don't want to do that yet. I want to say git log. The last commit was episode 99. We didn't have a commit for episode 100 because that was kind of an explanation. It was the milestone video. So this will be for episode 101. And let's see. And if I say git status, there shouldn't be anything here. Correct. Okay, so no code changes, and that is good. Now, first thing that we're going to do is we're going to fix something that we have been missing. How about that? Let's do this. Let's say we're going to edit, not the make file yet. We're going to edit our include tang.hpp. And this is, it's where we put, this is our to-do. We have all of our pound includes. Well, we're supposed to have all of our pound includes, but I got lazy about adding them. And so guess what we're about to do? We're about to add them. Of course, I don't know of a fast way of doing this. But okay, we're going to do it here. So, let's see. That might be uh, one of the one of the fastest ways. So I know we're going to have to do pound include. Uh, if we're going to try to stick with alphabetical order, then let's do this. AST node.hpp. You say, Corey, that's not alphabetical order. And I would say, sure it is. We're just going to have to do these one at a time. Array. Assign. Binary. Boolean. Break. Cast. Continue. And there may be a faster way of doing this. In fact, there probably is. I just don't know what it is off the top of my head. Float for function call declaration FIER identifier if else. Just put it in the wrong place. There we go. Index. And of course, all of this reminds me of all the work that that we've already done. Library, map, period, print. How many more do we need? Maybe 10. The range for the return slice string ternary unary use while, and that's all of those. Okay. And now for the computed expression, there might be 20 of them. You say, Corey, aren't you just going to copy them? No. Array, Boolean, compiled function, error, don't want it on visual, there, float, integer, iterator, and iterator, a bunch of library ones. Library base, there. Library math, library Tang, map, native bound function, native function, native library function, and string, and get rid of those. Let's see, context. There's context. Error. Do I need the escapes in here? Yes, I will. Okay, so There. After error. Escape. ASCII. How did I miss macros? Then opcode. Percent encode. Program. Tang base. Oh, ST node can go away because I've already got that. No, not Tang. That's this one. Tang scanner. Unescape. And Unicode string. All right. Now, let's see if we broke anything. Oh, because I'm in include. Now, I don't think it will, but if this works, we'll do a commit of it to just say that we fix it, and then we will start. The big picture is anybody who creates, what am I trying to say? Anybody who creates a library needs to be able to access any of these types, right? So they need to just have one include that will include everything. So that's what this is. We're making our way through. So where is the problem? When we are trying to compile test.cpp, I didn't expect to be running into problems this early. It's actually in the include of computed expression library base. Oh. Because this is meant to be something that you can use. It's not meant to be included. That's right. I had forgotten I had written it this way. That's fine. Library base. So it should not be included in this. All right, all tests are passing. That's good. Only one file is there, our diff. To tang.hpp. All right, that's fine. I can live with that. Now, let's actually see what we want to do for our library. Now, this is going to be a test library, right? We're not making an actual library that ships with it because I want this to ship by itself. So, what I think I'm going to do, let's go into test and let's touch a test library.cpp. Yeah, I think that's what we'll use. We'll use test library.cpp. Now, what do we need to do? Let's look at our make file. When we compile, so this is a test library, right? So test.cpp, Unicode, but it's like our target. Kind of, sorta. So I'm just gonna yank these 5. Say, Corey, shouldn't you have this better figured out? Maybe. And this is going to be called, what did I say, test library? Lib test library.so. Yeah. What is its dependency? Its dependency is not this, but after /target. So yeah, and then let's add include tang.hpp. So if something happens to that, then it will do that. So compiling test library. All right. -o is that. But what's our include look like? Is that it? Tang library? Oh, that's telling it where to look. So, okay, well, we will include that. I didn't mean for that to happen. Evidently, I don't know how this program works. Just bad. There. And, or do I even need that? I may not even need that. In fact, I don't think I need it at all. I think Maybe I don't even need this as a dependency. No, I'll leave that as a dependency. Oh. Okay, I think this is going to work. Now, for there, that's what I was trying to get. I think I need appdir / libtest bray.so. Not that I'm including it, but rather that it's got to be made. Oh, which means it's not that I need to recompile. It means that for my tests, it's a dependency. Yes. Okay. Because my test is going to load it, so my test is not getting compiled with it. All right. Now it is going to not like something. What did I do? Oh, when compiling yeah, I need to back this up. That is, not back it up as in save, but rather I need to go back and fix what I was trying to do. Okay, so my C++ flags are all of those. Dash shared dash O build apps lib test library.so, and then oh, normally I would have what I'm building, of course. So I don't need the target then. Well, I was using that as a proxy for if any of the .h files change. I'll leave it there. But I need test / lib, or did I just call it .cpp? Okay, and now it should say can't make it because it doesn't exist. Okay. cd test move test library to lib test library for right now. All right, and go back because I've got another problem with my makefile. And I think it's the LD flags that I've got a problem with. If I just get rid of those, okay, so I think maybe my LD flags was fine, and this just should have been that. Okay. We're going to find out. So, now we need a couple things. We've got to have... Let's just start with our test. And we're going to go down to the bottom and, of course, add, and we will say test custom library load. And now this will be how do I load Tang is the question. Yes. There. So that way it's not messing up anyone else's. And what I want to do is I want to call Tang, it's a shared, that's fine. And say load, I think, right? Load library and give it a location. And what did we call it? Lib test library.so. And then, what did I do? I had a test a long time ago with loading something, and I think we're going to steal. Where we added a custom function. Maybe I'm thinking about this way too hard. Went to the wrong side. That's okay. Of course, that's not going to do anything, but it should, well, it's not going to compile because I don't have this load library thing. So that's what we're going to do next. Yeah. So in order to do this, we need to edit our include for program.hpp, and we're going to Yeah, I'm going to do it this way. We're going to say param is going to be the path, and that is the to the shared library. And return true or failure. False. That'll be pretty easy. Okay, so bool, and this is going to be load library, and we'll just pass in a let's do a string called path. Definitely not a const. Okay, now we want to edit string. While that's doing that, we want to edit the include for program. Not include, source. We'll just have something bool program load library string path. All right, now we're to the point where we get to do something interesting. What's it wondering? Syntax error. Oh, that should be a $sign there. Don't know how I missed that earlier. There we go. Why am I putting this in program? It's not in program. It is in Tang base. All right. And I just quit. Vim. Let's do test.cpp and our test lib that are our include for Tang base, our source for Tang base, and then the one that we put in wrong, include for not a capital P program. There we go. There, that's out of there. Okay, B. Now we'll do our Tang base, so this is going to be a bool. It's like, why is it taking so long? Undefined reference to load library. That's fine, because I had not put it in place yet. Oh. Return false. Yeah. So let's see. Let's figure out how to load a library, shall we? I had some notes, so this is going to be different per number 4. For each, what am I trying to say? For each operating system. So what do I need? I need DLFCN. So dynamic link function, maybe .h. Anyway, yes. And so this is going to be kind of boilerplate, but not really. So I'm going to call this just a library handle. But I call DL open, and then I need the path, but that needs it as a, does it need it as a C string? I'll try not. And I'm going to, for right now, say go ahead and load it now, and DL, no delete. So that means I want to be able to unload it, but it not go out of memory. Does that make sense? So that means if it's succeeded. Otherwise, return false. Okay. Let's just go for this at the moment. Of course. Fine. Let me go ahead and write a little more. We need to reset any errors that, although there shouldn't have been any, but oh well. And now we're going to look for a function. Yeah, so let's call this, so it's not in Tang base, but we'll just say what do I want the function to look like? Well, first of all, what do I want to call it? So let's call this Tang library init. It's going to be void. It's just saying that it's a function pointer, and what will it take in? A shared pointer to Tang base. Will that work? Ampersand. That may work. Okay, the only problem is Tang base isn't declared until right here, so I actually need to do a forward declaration. And if this works, then we'll do our documentation layer. I don't like calling it init. Initialize function. Tang library. How about custom library loader? I think I like that better. And just see if that... oh, well, we're seeing a couple things already. Tang custom library loader is that. There we go. So our function pointer is going to be one of these, and we'll just call it func, sure, why not, is equal to, and we've got to cast it to that, Tang custom library loader, and then we call DL sim, give it the library handle, and tell it what we're looking for. And there, Tang custom library loader. That's the name of the function we're going to look for. Now, first of all, it doesn't, I can see over here, it doesn't like this string to a const char star. So I can do that by asking for the .c stir. You know, this could be a const string ampersand. I'm going to have to const string ampersand. When I do this, is going to probably redo a lot of stuff. All right, so it's saying, hey, I don't know what you want to do with func. That's fine. I can do a const char star deal sim error. I'm asking for the error is equal to DL error. I want to do this? Yes. I want to close the library handle. If there was an error, then in path return false. Okay. Now if it did work, then call func and oh, how do I get a, there it is, and give it this shared from this. All that I had to do was look up here because I called that before. All right, so that is what we're hoping will happen. So if I can't open it, then it's just going to return false. Maybe return true. See error. Load library. At path. All right. Oh, it doesn't like the ampersand. That's fine. Okay. So, and that makes sense. There. Now, what do we do? What do we do? Okay. I'm okay with this. Because it says that it's, is there a C? Yeah, could not load library at path libtestlibrary.so. It returned false, and I said it should have returned true, so my test is returning false was correct. Why is it not doing libtestlibrary.so? Actually, so build apps. There is a libtestlibrary.so at that where it's running. So is it that, well, we're about to find out. If I go to build apps and I run /test here, cannot open shared object. Which one is that erroring on? Cannot load. I'm here, and if I try to run Tang, is that because, okay. And it runs it from here? Okay, that's a mystery for another time. We'll come back to that. It's like, oh no, this always makes, it worries me. I might not be able to solve it. Well, I mean, you can always solve it. But what I want to do is I wanted to try to write this function, libtestlibrary.cpp. Actually, so pound include tang.hpp. And now this is, what's the name? There. Tang custom library loader. So this is a problem with, I'm not telling it where to look for the .hpp, am I? No, I'm not. So that's fine. There. So the LD flags, user lib, all of those. CXX flags. Includes, that's what I need. Did I not include? Did I not include? Possibly. So when I'm compiling, after CXX flags, I should have put include. All right. What? How was Tang base not declared? So libtest library, line 3, Tang base is not declared. That should have been included in the include. That's why. This will give me a complaint about it's unused, but that's okay. Maybe unused. Did it compile that? Oh, yep, it did. All right, so it's still not finding it, but it's could not load library. So at path, whatever, libtestlibrary.so. Hey, that's a different error than it was giving us before. So it couldn't find that. What I think I want to do is here at the end, if I were to put that, first of all, will it change anything? I don't think so. I'm going to try. Okay, this different error. Before, it was, come on, there we go. Could not load the library at the path. Now the error is, could not find that function in the path. Okay, and why? I know why. It's because of C++ name mangling. I'm looking in here, I'm looking for this exact name, Tang Custom Library Loader. And C++ does name mangling, which is how we get not just operator overloading, but function overloading itself. And the namespaces and everything like that. It changes the name of the function, and each compiler does it differently, and it's really impossible to predict. But you can just say, no, don't mangle the name. How do you do that? By saying, yeah, this is going to be used by a C library. Sure. And we do that, so let's go to B2. There we go. All that we have to do is extern C. Look at that. Just going to stop and say it loaded the library. Yes. Okay. What all differences do we have? So we added the makefile for the library, added it as a dependency for the tests, added a, oh, I need to vim, this is in Tang base, include Tang base.hpp, and we'll just say that this is custom library. Name mangling. There we go. Okay. I've got my load library function. I've got it loading a library. I've got it giving me errors, and I've got a test. The only thing is well, we're going to do this, and then we're going to make the library do something. And this is all right. Now, let's go back and what I'm looking for is we had a custom method. Well, this was on a string. We'll use the context to store a variable that it will increment each time that the function is called. So did we only put that there? Maybe we did. I mean, did we not have another one? We had it on that. let's start with that. We'll start with that one. And to do this, we're just going to say right here, Y33. There we go. I'm going to remove this maybe unused. Let's see if this compiles. Oh, do I need to add the fpic? That's fine. Nope, I'm not going to do it here, though. And the fpic is that, well, did I say fpic? Yes. That is, I used it earlier when I created, well, with all of these others, didn't I do it? For all of the objects, yep, I did. I used a -fpic, and that's the flag for position independent. See, I don't remember. But that's what I need to add when test library. Okay, so it compiled. That's always a good thing. How do I use this? Oh, no, wait, this is a different native function. Custom function. There we go. And this should just print out 0, 1, 2. Yeah. Six, 7, 8, 9, 10, 11, 12, 13. There. Now it's got syntax highlighting turned back on. And it should print out 0, 1, 2. And it must have done it, because if I say 0, 1, 2, 3, recompile the test, rerun it, it did fail. Good. No, I mean, it's supposed to fail. And now, if I do this again, but don't load this, well, I'm going to leave it on EQ, just because this should be a bunch of errors. Well, I mean, it's not going to print out the errors, but it shouldn't print out anything. So it should fail to say there was no output. And that's what I wanted to say. So we can say not equal, now it should pass. And the point was, is I had one with the library, one without. Yes. All right. So what does this mean? Well, what we have is we have a way to say, hey, load this library. That means a third party could compile something and extend our library's functionality simply by implementing, right now, one function. And that function is this Tang custom library loader. So we're just going to say this is a custom library loader function. By the Tang base object. Okay. At param Tang, this is going to be a shared pointer to the Tang base object, and it does not have a return type. Oh, I just wrote that here. You know what? Fine. We'll just leave it. I'm happy with that. And I think one other thing I'm going to do is at the very end here, if I well, I expect it to be false, and I don't need to run any of the other stuff. It's just I expect this to fail. Expect it to fail, just making sure it's running, and then I'll change it to false, which is what it should be. Verify that it's passing. Question is, do we want to leave it printing out to see error? Don't know. I'll think about it. But for now, this is loads should have as necessary. That's fine. And then the last one is should not impact any other Tang base objects. Yes, I know it's too long, but that's because I'm just going to change some stuff anyway. Tang base objects should not impact any other Tang base objects. All right, that's what I'm testing in those three. Again, I expect that to pass. And you know me, I prefer to say sure, just let everything build and get diff, see what our diff is. lib test library.so. Okay. Now, everything's working. Last things that we need to do are make docs-pdf, update our documentation. I mean, we did a lot to the .hpp file, so that's going to be some changes, and we'll get this wrapped up. For episode capital E, maybe 101. Didn't have to look it up this time. All right, and episode 101 and -m. And last thing that we do, make clock. There we go. Tells us how many lines we're using, around 12,300 and 3,600 lines of comments. And hey, I'm just going to point out that when I first started, I said this might be around 10,000 lines. Okay, so I was off by 20%, but not too bad. And forgot, well, I'll do it next time, but we can actually remove something from our to-do list, and that was the ability to have libraries, third-party libraries. Now, why would you want that? If we can just take a step back and think about, why would this be a thing? And the answer is really quite simple. If you visualize Tang as a library that ultimately maybe gets packaged in a distribution, say Ubuntu, you can do sudo apt install Tang, and it would install the libtang and its header files. And you wanted to use it in a program that you're writing. Or maybe another program is using Tang because it's a game or well, I doubt a game would use this, but it's right because this is more for HTML, and at least that's the intent at the moment. But okay, so fine, whatever program is going to use it, then you want to write an extension to it. You write your extension, you #include tang.hpp so that you can have all of the definitions, and then you compile yours, and then you tell that program, because somebody else wrote that program perhaps, that, hey, load this extension file, this module, maybe you want to use that word. And you could almost think of it maybe in the way that PHP has its mod files, mod this, mod that, or Apache had, or was that Apache that has the mod files, the module files, or PHP had the different libraries that you could tell it to load. And that's what this is. It is the ability for a program to just say, here's the path, Tang, load that, and then Tang and this custom library communicate, and it can add its functionality to Tang. That's the goal. And yeah, and that's what we've got, which I'm really happy for. So, having said all of that, I believe we can call this a day. Oh, I don't need to change anything on typing. You've already seen that. So once again, thank you again for joining us, and it's good to be back. Got a little bit of a break after I did 100 episodes in 100 days. And some of these episodes, have been 3.5 hours long. Some of them, very few less than an hour. Today's an hour and a half almost. So it's been a lot of work, but I'm really happy with where we are. And I was dreading this. I'll be honest. I was dreading it, and I had to look up a little bit of stuff about how do you load into .so files. I didn't know about needing to use the PIC. I don't even remember what that stands for. The something independent position independent code. Maybe it's code. Maybe it's something else. I don't know. Anyway, but once I saw the error, I was like, oh yeah, that's what you need. So I didn't have it pre-done, but I didn't know how quickly it would come together. There's other things that we can do. We could extend it so that when you enable one library, you let the other libraries know that you are enabling another library by a certain name. You could do all of that. Not worrying about it at the moment. Why would you do that? Well, what if you have one library that can add a functionality, but only if another library is loaded, and they get loaded in the wrong order? Well, you could then say library A is looking for library B, but you didn't know that they needed to be loaded in a certain order. So when library B gets loaded, you need to notify library A or all the other libraries that are loaded that, hey, I loaded this library, and it might say, oh, okay, well then I can do X, Y, or Z. So there's a thought. So I'll think about that some more, but for right now, we're in a good spot. Thank you for joining me, and have a great day.